little bit. So I want to touch on that maybe to stimulate your thinking. It's not too long, but I will not do it today. I am just giving you a heads up on this, that there is something interesting. I mean, I may have kind of gone from one end to the other end in terms of introducing the basic aspects of hydrograph to talking about plants, talking about infiltration to global scale stuff, right. So, it is all over the place, but now when it comes to tying all the ends together and coming up with a plan for understanding how do you go forward. I mean, you have to develop an understanding of all these things when you are running the model, but as a next step, if you are thinking about using some physics guided models and AML techniques to predict hydrologic extremes, this paper is a very good one for you to refer to. So, please consider reading it after I discuss with you. There is some discussion on this. I will not do it today. Like I said, it is only a very quick 17 slide discussion that I will have on Saturday when we come back from the field trip, but it will at least help you. So, I am going to wait for that moment. Let us actually, as per our plan, we should start talking about drought, because drought is such a vast topic and we need to really, we are again swinging back and forth between one extreme to the other extreme, right. When you have plenty of water, it is a problem as floods. When you have no water, that is also a problem as drought, right. So, that is a challenge for us to predict both extremes, but that is also an opportunity for our contribution to science in terms of what can we do about it. So, drought is one of the natural disasters. So, I will have tons of papers on this. I have been working on the topic for quite some time now. I will not go through all those case studies. It will not be worth your time as well as anybody's time. So, what we can do, we will go through all the concepts that we have kind of generally drawn from those. I will make the papers available to you. You read whenever you have time between now and before the end of this course. After also is fine if you want to communicate with me about those specific papers, but we are presenting now how you can understand the concept about basic droughts. Drought is such a vague term if you think about it. So, let us start drilling down to the details. It is a natural disaster, right. It negatively impacts water resources, agriculture and economy, that we know very well. Global surface temperature has increased. These changes have concerns about the impacts of droughts. You saw, I mean, you have to now tie all the connections here, loose ends. We talked about increased temperature, feedback. If you look at the feedback process that we talked about yesterday, whether it is cloud formation to soil moisture evaporation to how it contributes to increased sensible heat flux, how it really creates the drier conditions. You have to kind of bring all those things together when we talk about drought, right. So, global climate change is something that you have been exposed already many times. So, what is drought? It is basically defined as a below normal precipitation over a specific period. We are supposed to get, let us say, on a monthly basis here, I am thinking 120 millimeters or something like that. If you get, let us say, 50 millimeters in 1 month, and if you are below that month, average month, then you can call that as your drought condition. It is kind of, slow starting process. It is a creeping disaster that we call, because it develops slower and often unrecognized with indirect consequences. When the rain does not come, people will say, oh, we should have gotten this rain, but we did not get. So, people ignore and probably move on, right. But only when it persists, it comes to your mind saying, wow, we are now not having water, no rainfall for the last 1 month, 2 months, 3 months. So, you saw some regions within within India are more and more exposed. Marathwada region, for example, if you look at, it is one of the driest region because of the rain shadow is one thing, right, on top of all the other aspects associated with that, maybe more radiation, less retention of precipitation that you have, what not, all kinds of things. So, it is a slow moving disaster. it's a disaster and it can also spread over time. A period of abnormally dry weather with lack of precipitation to cause a serious hydrological imbalance and carries connotations of a moisture deficiency. So, that is another way of defining it. It is word, mouthful of words here, but abnormally dry weather is a starting point for drought, you should understand. So, when you see, you have to get the rainfall on a specific time, right. If you do not get that on a specific time, it departs from the average conditions and decrease of water availability in a particular period over time. That is what we can say even with respect to vegetation drying up, for instance. Another definition is a condition where the amount of water which has been expected and relied upon for use in any of man's activities cannot be met for some reason. So, we have defined how much we need per day in terms of city people, right. City water supplies calculates that and distributes that water. Where do they get that water from? Maybe from surface water sources, tanks and reservoirs, but they also get from groundwater. They pump that water, put that in this tank and then supply that, right. But if they do not have that water that is available to them, they cannot supply to meet the demand, then that is also considered to be drought, right. So, many definitions, but there are problems in defining droughts, there are problems in predicting droughts and problems in mitigating the impacts of drought. So, there are so many levels of complexities here, we will break it down one by one. So, it is hard to know when it starts, because in front of your eyes you missed getting normal rainfall for a given monsoon season. You will think, okay, it will come maybe another time, but before you realize that if it does not come, it starts setting up. So, you have to then backdate your starting point even. Oh, last season we did not get enough rain, maybe that was a starting point that we did not realize, and the drought start continuing into the second year also. So, that beginning and ending point is very difficult to predict. Drought definition can lead to confusion due to the absence of universal definition of drought. It is a broad term, there is no universal agreement on what we call as one single thing. For floods, we have a clear definition. For this particular location, if you have more than the channel capacity, you call it a flood stage, right. For drought, that is very difficult to say, because it has got lot of other social implications associated with that. Drought impacts are non-structural hazard and spread over large geographical area. So, it is widespread, it is like smog in the atmosphere, right. It can really spread over a large area, and the impact is, of course, can be detrimental for everything, both humans and infrastructure. When we talk about drought, there are specific definitions. Meteorological drought, that is one type of drought. When there is lack of precipitation or below normal precipitation for a specific period of time, we call it meteorological drought. It can be from few days to few weeks, it cannot go beyond that. Few days means, when I say, let us say June precipitation, we should have gotten, let us say for Warangal 150 millimeters. If we do not get it, maybe you can call it as meteorological drought. What is agricultural drought? A period with the scarcity of soil moisture and leading to crop failure. So, there are combinations of meteorological and hydrological factors associated with it. So, that is called agricultural drought. So, when I said for meteorological drought, June month is the time when you miss rainfall, short time period you ignore it, right, saying you may get in another month like July or August, you might compensate what you did not get for June. That might be a, kind of a wishful thinking, but what if you do not get rainfall in July? What if you do not get rain again in August? So, it extended from June to July to August now, 3 months. So, that is the actual growing season. Probably people want to take advantage of monsoonal rain to raise paddy. Without irrigation, they can use this monsoon rain to cultivate crops, right. They will not be able to do that. That leads to agricultural drought. So, that is the crop season calendar that you can call roughly for the period of growth of crops. Hydrological drought, what do we mean by that? We saw the annual hydrograph. Let us say this is an annual hydrograph, right. So, in this case you have 4 months of rain in many regions of India because of monsoon. If you do not get that rain, many rivers start drying up, but they do not show right away. They do not show right away. Ganges, leave Ganges, because they also still get snow melt runoff from the Himalayas, but I am talking about the rivers that are fed by the seasonal rainfall like monsoons, okay, whether it is Krishna, Godavari, Kaveri, Pennar, whatever, all those rivers that we have that depends on this monsoon, whether it is southwest monsoon or northeast monsoon coming to the region. If you do not get it, at the end of the season, your hydrographs or the rivers that you see will have low heights, low peak flows, low volume of runoff that you have. That is hydrograph, that is a hydrological drought, that is hydrological drought. The next one is socio-economic drought. Okay. So, I think this is increasingly gaining traction now, because drought means it is not just we are talking about natural systems, whether it is crops or rivers. We are also talking about the people that are needing this water to be shared. They are going to be impacted. Poverty increases, food famine starts, all kinds of socio-economic conditions develop. So, there are metrics to quantify that socio-economic droughts. So, when water supply and demand is not met, you are going to have implications on many levels. So, that is socio-economic drought. Groundwater drought, what happens to your aquifer? When you 1 year if you do not get rainfall, maybe it will not drop too fast, because these aquifers are large in size underground. But if you do not get rainfall for consecutive 2 years, 3 years, then you can clearly see the water table drops, goes below, and that is called groundwater drought. And on top of that, people, when they do not have enough water for agriculture, for drinking, or for other purposes, they start pumping water during drought. So, they even aggravate that. It is a positive feedback, right. When you have drought, you are pumping more water and it creates more drought, because you are probably depleting water more from these aquifer systems during drought. So, that happened even recently in many places, including California. They happen to see that. So, another important thing that you need to understand, it is based on this run theory that people have derived some terminology. Whenever you read drought literature, they talk about couple of variables. So, I am going to talk about those things here: severity, intensity, and duration. And there is also, of course, the other part that I wanted to mention, the areal extent of the drought is very important for us to consider. So, the initiation time is important, termination time is to be known, drought duration and drought severity and intensity. What do they mean by the drought? Let us say this is the average condition, right. Assume this line as an average line. If your rainfall does not happen and then you start seeing the deficit rainfall, that is the starting point for the drought, right. That is the starting point for the drought. And again, if you do not get rainfall enough, it continues for some time, and that is the duration until when you hit back, when you come back to the normal condition of rainfall, let us say, based on rainfall I am saying here. So, this drought part that I am talking about, right, this drought deficit rainfall that I am talking about for a certain period, the duration that we have here, right, has got higher severity. Why do I say this is positive side on the left side, up, down is negative. So, you can see probably it is going deeper, meaning significant deficit rainfall that we have. In the second case here, if you look at, the severity is not there, right, severity is not there, but the spread of the drought starting point and ending point is there. So, it is called the longest duration drought that what we are seeing here. And think about the third one here, you have a much intense drought deficit conditions, but for a shorter time it immediately recovered. So, to come out of this situation of such a deep drought, you should have had some hurricanes or cyclones and tropical systems bringing heavy rainfall that saturates the whole area, breaks the drought cycle. So, all this ending point and becoming normal condition here, this point I am talking about, this point, from deficit condition to positive side, same way from deficit to positive, another one, it has to have extraordinary breaking in the system, extraordinary out of normal condition, meaning the drought should be immediately quenched, the thirst of the soil, thirst of the empty reservoirs, thirst of the rivers, they all have to be met with heavy amounts of rainfall, then you will start coming back to normalcy. So, you have the duration of the rainfall, intensity of rainfall, and then of course, starting point and ending point, right, and then the severity aspect of rainfall. And now, one thing that is not apparent from here is the areal extent, because drought does not happen in one place. If it happens over a large area. So, then you are talking about the socio-economic aspect of it, right. So, but primarily quantifying all these things is very important, to quantify or to map the drought extent. There are techniques available, that is what we are going to see now in this next few slides. These are characterized by multiple hydrological and meteorological variables, right. I am listing all of them here. I think this, we are starting with precipitation always. When you have deficit precipitation and the temperature, when you have more or high, it impacts more evapotranspiration, depletes soil moisture or reduced stream flow, that decreases soil moisture and depleting groundwater. So, these 6 of them that I am showing here has got a direct effect on drought, right. They are related to drought, tightly connected to drought. So, if you take any of these variables and integrate into calculating drought indices, you might be able to quantify the variables that I was talking about before, like initiation, duration, severity, intensity, areal extent, all of those things you can still come up with. That is the main thing that I wanted to emphasize in this slide here. So, this part again I am going to emphasize, like I mentioned in the plant that I showed this morning, consider this part like a small column of soil that is holding field capacity, wilting point that we already discussed here. This column, the available water is between field capacity and wilting. Field capacity is the highest point, wilting point is the lowest point. If the water goes below this point, plant is dead, right. So, this is the actual available water for plants to extract moisture. So, we want to quantify drought conditions based on available water content or soil moisture condition. Based on soil moisture, that we can come up with what is the drought condition that we have in the watershed, for example. And again, when you have more moisture, you have increased ET, right. When you have less moisture, you have drought conditions, right. When there is low precipitation, you have drought conditions and soil moisture deficit increases, and then you have to really quantify whether or not intense drought, how intense is that, how severe is that, and all that, right, based on soil moisture. That is one approach. Based on precipitation is another approach, and there are statistical approaches. So, these are some of the indices that I am going to talk about. Standardized precipitation index, this data is already available on a global scale for maybe varied degree of resolution. Basically, I am talking about 2 by 2 degrees they started with, but then in some places they increased to 1 degree to half a degree, now 10 degree or 0.1 degree, something like that they have come based on the intensity or density of rainfall. SPI is the most popular index because precipitation is measured in many places, right. So, it is easy to calculate, they have a mean. I mean, it is not too difficult to extract the condition of the drought based on precipitation. You have average precipitation, any departure from that average you can categorize as drought. That is what they do in SPI. Okay. In SPI, any departure from the long term average, if it is below, if it is negative, you can say it is a dry year. If it is above, you call that as a wet year. You can do that same thing on a seasonal basis, you can do that on a monthly basis or a weekly basis, because precipitation is measured mostly on a daily time scale. So, you can even come up with drought index based on precipitation on a daily time step. Do you follow what I am saying? You can calculate drought based on daily time step very easily. And then this particular entity where I was part of in the beginning, called US Drought Monitor, started in University of Nebraska Lincoln. They kind of used couple of standard drought index, for example, Palmer Drought Severity Index, SPI, Keach-Byram Drought Index. These are all different types of metrics they used, 7-day average stream flow, precipitation anomalies, and then they came up with, I think I probably have to show you this map first, and that way you can understand. So, they came up with a spatial map like this. Before they even put a red dot on the map, what they did was to call the water people in those agencies. Nebraska is somewhere here in the middle of the country, right? Nebraska is here, but they reached out to all the people on a weekly basis and say, hey, did you get enough rainfall this week? Hey, did you get enough rainfall next week, or whatever they want to compare. Do you have enough storage in your reservoir? Do you have enough crops growing? Do they need enough, do they have enough water for irrigation? All kinds of questions, survey questions they have. On a weekly basis, they really sent out those questions to people to fill out based on what they say, based on the survey, and then based on the real world data of precipitation, stream flow anomalies. They came up with a map. It is a pretty hard work basically. Every week Thursday afternoon they release this map, US Drought Monitor. You can even go and check out this map for India. I think similar map was started in India also by some other groups in India. IITM I think is doing that also, or maybe other institutions like Gandhinagar IIT. But the takeaway here is this: there are categories they define, D0 to D4, abnormally dry, like in these yellow regions, right? When they calculate precipitation and say, oh, they are not coming enough for this week, they call them as abnormally dry conditions. To moderate drought, severe, extreme, exceptional drought is the red dot or dark brown dots here, right? So, you can do this for every county. I would say county in US terminology, county is equivalent to our districts here, okay, similar to districts, or maybe smaller than district also, counties. For every county they have statistics, they have numbers, they have weather data. They were able to pull all these things together and come up with a map. Okay. India has somewhat similar approach also, like using IMD data for every district. But now going back to this USDM, they produce weekly maps, and of course, you cannot get the local scale information from this map. It is only broad approach to this whole exercise of coming up with a map, but it is a lot of work. But then they have automated this process, but then again questions came up, why are we not using one index versus the other? So, for example, PDSI was Palmer Drought Severity Index, meteorological drought index, based on combination of both meteorological conditions, hydrological conditions, soil water model, balance model is used in this case to come up with PDSI, right? And PDSI calculation is not that simple, it needs all these variables, and even though it is widely adopted, there are some uncertainties associated with PDSI, but it is widely used or developed and these indices are also PDSI. If you search on a global scale, there are numbers for any region in the world that you can get PDSI. And if you plot just for your watershed, how many times that you have above and below the normal conditions, based on that you can start considering what kind of further analysis you can do. I am not saying that you will start there and stop there. It is any drought analysis, when you want to do, you take the existing calculated metrics like PDSI or SPI, but then you can improve on them based on your local knowledge. Okay. So, I will not again go into the details about doing that now, but in the next few slides I will show you. So, there are some shortcomings for this also. Many times this PDSI is based on potential evapotranspiration, right. Potential evapotranspiration is another big terminology that I think I need to explain here. When you have plenty of energy from the sun, when the plants are having lots of leaves, we assume that there is no limitation for moisture in the soil, it is energy driven. So, it will transpire at the highest rate, and that potential evapotranspiration is not really similar to the actual evapotranspiration. If there is no soil moisture in the ground, if the plants cannot take that moisture for extraction, then your ET is less, right. But they consider potential ET for calculating PDSI, which is not the right metric. That is one example of why PDSI is not reliable. I am giving you an example. But there are other things like assumptions of all precipitation is rain. There are snow regions available, and how do they accommodate when the soil freezes, and then slow response of developing and diminishing. So, it is very difficult to really quantify the starting point or ending point of the drought based on PDSI. Again, precipitation data is not available. I think you brought this up for PMP calculations, but I am saying that same issue will come for PDSI calculations also here. Again, there is soil moisture condition, reservoir storage data that we need for that is not available. There is another model or index called SWASI, SWSI or SWASI they call, surface water supply index. Basically, it is the amount of water that should be available for as supply, and if that supply is not available, they call that is a drought condition based on this index. Supply side of water balance equation. Primarily in the US, especially on the western part, they are all snow melt dominated watersheds, meaning you can predict drought based on the winter snowpack that accumulates on these mountains. If you have enough snowpack, the snow season typically starts from late November and it goes all the way up to March, end of March, roughly about 4 months, 4 to 4.5 months, give or take few days here and there depending on the region. So, we are talking about December, Jan, Feb, March, 4 months they get lots of snow. All these mountains are packed with snow. So, the forecasters, the snow people go and measure the depth of snow and they say, wow, we got 10 feet of snow this year, this is going to melt to 1 foot of water. I mean there are conversions based on the density, based on the wetness of this snow conditions, they can convert snow into water equivalent, snow water equivalent. Okay. And then they come back and say by April 1st they release the information saying California has got enough water for this season, because they got enough snowpack, because mountains are reservoirs or storage. Even Himalayas, for Ganges people do that too, because if they get enough snowpack for a given season, they can calculate how much water they will get in Ganga. That is possible, because monsoon rain is one thing, assuming monsoon brings normal rainfall, on top of excess rainfall, excess snowpack that you have for a given season, you are going to have plenty of water in the Ganges. So, likewise I am saying as an example, but they are all supply side of things. What I mean by that, if you have enough snowpack or if you have enough rainfall, you can then decide that your supply side is met. Supply is normal or above normal, so you will not have drought. If that is the case, if that is not the case, then you will say this year we are headed for drought. April 1st, all the western water managers or western US water managers release this information saying we have enough water, we have not enough water, and all that information, and farmers decide based on that information to put crops in the ground. That is, these people are considered God if they give right information about the forecast, about our the snowpack information at the end of the. So April 1st is a very significant day for them. Yeah, glacier melt is happening. Yes, I mean melts. Significant. Yeah, yeah. Yeah.
So whether they consider that glacier melt also?
Glacier, yeah, it's.
For example, in Ganges Basin.
Yeah, I think we are losing a lot of glacier mountains, right? Generally speaking, because of climate change, but it is, added to the snowpack that's already there. I mean, these glacier mountains also get fresh snow every year, right? So only if they don't get fresh snow, when the glaciers are exposed to sun, they will contribute to runoff. But in most cases, this glacier snowpack, of course, glaciers are retreating. At the same time, they are also, I don't know if I can, maybe I will show in another time. These mountains, let us say you have this amount of snow covering up to 10,000 feet from the top. So they call that snow line is receding, meaning the mountains are losing that snow and they are going minimum. Kilimanjaro, if you remember, in Tanzania, all the glaciers are gone now. Montana in the US, they lost, I mean they used to have 100 glaciers, now they got only a handful of glaciers, they are all gone. So it's like a fixed deposit. Once you start taking money from that, it's kind of gone, right, over time. So that is not totally, I mean it's important, but it's more than that. The snowpack and the rainfall that we get on a seasonal basis will help this particular index, SWASI. But other index I think are also available to calculate, ETDI for example, or soil moisture deficit index. This is what I use, or I developed one such index. These papers, there are, like I said, 20 of them that's available as soil moisture based, not soil moisture based alone, but soil groundwater storage and all kinds of index. So I will talk about or present those papers to you later, but I am just listing all the index that's available. Soil moisture index is an interesting one that I need to show you how we calculate. Maybe in the next class I will show, but I am just listing. Same way with evapotranspiration, people come up with a deficit. They know how much transpiration should happen for a given plant. If it does not happen, then they call ET deficit, and then based on that they can come up with drought mapping. So groundwater conditions are also used to understand groundwater maps, but again, based, like I said, there are 5 or 6 variables that I talked about: temperature, precipitation. I'll stop in the next 2 minutes. Precipitation, temperature, stream flow, all of those variables that we talked about, right? So they can actually be combined in the statistical framework to come up with multivariable drought index, multivariate drought index. PD, or they call joint probability distribution based drought index, that I will come up with a name for that. We have couple of papers on that also. So what I am trying to say is ET is used to calculate drought, and they use both for climate change conditions. Probably you saw BIST paper that I showed, 2019 paper, where we looked at climate change projections, right? But there are also drought forecasting done. You understand the difference between forecasting and projections, right? So far that we have discussed both. Projection means long term, forecast means for shorter term. So, drought forecasting is being done currently for up to 6 to 9 months. For that you need good data. Which one is very, very important for that? Precipitation. We do not have good precipitation data up to 9 months forecast. We do not know what is going to happen 9 months from now for precipitation, but rest of the variables we can easily calculate. But drought forecasting is a very important aspect that we will start from there in the next class. I will start about multivariate drought index, and then Coppola is another one that we use. Then we will come back to using the model to calculate drought, and I will show you how we have done for different places, how we quantified, how we mapped drought, and how it is useful for making decisions with respect to water management. We will kind of end with that. So, by the way, these are the two models that we use for calculating, and again one of the models we will discuss. We discussed in the morning also, but Wick model is widely used, but we are using SWOT model for most of the drought cases, which is very effective. Soil moisture developed from this is useful. I will start from joint probability distribution here in the next class, and then continue. Probably by Saturday afternoon we will have a better understanding of what we mean by drought. So, today we talked about basics of drought, definitions of drought, what are the variables, how do they define drought, and what triggers drought, those kinds of things, but we did not get into the technical details yet, but we will continue that on Thursday or Saturday after our field trip. With that I will stop. Do you have any questions for me? I know it is getting late. I know I got only one, and no, I think I started by around 10:50 or so. So, I took 2 hours anyway. Good. Questions? No? You are all completely clear with everything that is covered, right? It is all simple anyway. So, we will talk more. Okay? So, we will stop here for lunch. We will convene again at 2:15, I guess. Heck HMS is the model. It is working. Good news. So, we have our demonstrator coming up with a good plan for today. Once it is finished, if you have time, we can do the rest, whatever left over from the previous days, but it may not take too much time today. So, we can be done in 2 hours, hopefully. Okay? We will stop here. See you again. Head for lunch. I know it is getting late. I know I got only one, and no, I think I started by around 10:50 or so. So, I took 2 hours anyway. Good. Questions? No? You are all completely clear with everything that is covered, right? It is all simple anyway. So, we will talk more. Okay? So, we will stop here for lunch. We will convene again at 2:15, I guess. Heck HMS is the model. It is working. Good news. So, we have our demonstrator coming up with a good plan for today. Once it is finished, if you have time, we can do the rest, whatever left over from the previous days, but it may not take too much time today. So, we can be done in 2 hours, hopefully. Okay? We will stop here. See you again. Head for lunch.